word. It's challenging. I'm going to throw some metrics over here. Modernization has always been a difficult pill to gulp. It's always considered high cost, uh, very time consuming, generally measured in months and years, and also generally considered very risky, right? And you can look at a number of reports. I would say this is a lower end of the figure. Modernization failure rates are typically very high. 70 to 80% of modernization programs fail. So for the last, I would say, a couple of years, it's been almost our mission to how to sort of improve this cost, time, risk, value equation of modernization, right? Like as much as the techie side of me might want to believe it's the clean code and the brilliant architecture, all of these decisions are based on this equation, right? So that's what we've been focusing on. And we've been trying to do that with AI and friends. So there you go. If anybody's got the bingo card, we can start right now. I'm Shodhan. As mentioned, I hit 18 years in Thoughtworks last week. I don't know if that's a good thing or a bad thing. I'm tech slanted. I always make this joke that I know more Google slide shortcuts nowadays. But yeah, there you go. Jonathan, do you want to say a few words?
Hi everyone. Oh, sorry about that. Hi everyone. I'm Jonathan. I'm a software engineer. I've been working for Thoughtworks for only 7 years. I mean, it's a lot of time or not enough time, depending on where you stand. And yeah, for the past couple of years, I've been working on the application that we're going to talk about.
Thank you. So some definitions to sort of get to the same page. What is legacy? Although the word has this English connotation of old and new, um, generally legacy systems are characterized by some notion of not fit for purpose, and the purpose and the fitness sort of changes from places to place, but there's some notion of like it's not fit for purpose. Either I don't understand it, or I can't change it to what I want to do it, I can't deliver the right type of experiences to my customers, or I'm sort of unable to sort of maintain it at the right sort of price point. But there's something about that's not fit for purpose, right? So it's not about whether it's old or whether it's new, it's about whether it's fit for purpose. And like the example I love to use is, I guess is an old one and I need to figure out a new one, is when Twitter was initially written in Rails, it was about 6 months old and they had to rewrite it in whatever, Scala at that time or whatever, right? Like, so again, it's about fitness for purpose. Whatever they had didn't work, so they had to change it. And so if legacy is about things that are not fit for purpose, I guess modernization is about changing them to make them fit for purpose, right? And again, because different organizations look at that fitness for purpose differently, they have a different view of what degree of change they want, right? And so my mental model of modernization is almost that it's organizations who want to build something similar but also something different. They want to build something different because they want to solve the problems of their current system, right? Whether it's hard to change or hard to understand or whatever that was. But they also want to build something similar because most organizations don't have the luxury of starting from scratch, right? Like starting a bank from scratch, starting from airline from scratch. Like you just can't start from scratch. So they want some degree of similarity so that they can start moving customers over, they can start moving functionality over, right? So the modernization is always this fine balance of I want to build something new or different, but it has to be some way similar to the thing that's old, right? And the degree of similarity sort of keeps changing from place to place. Um, Luckily, it's a known challenge, right? We've got loads of sort of learned experiences in this space. I'm sure you've heard of some of these patterns: Strangler, Frig, domain-driven design, etc., etc. So there are well-established practices that help solving for modernization. And then if you sort of zoom out, right, like how do we solve for this? Uh, there's sort of this is sort of very high altitude journey of how do you solve for modernization, right? You understand the problem, so you understand why whatever exists is not fit for purpose. You understand the system, so you understand the details of the system, like what sort of how it's designed, how does it work, what sort of business rules, business logic it has. You figure out a modernization strategy. There's a lot of the cloud providers talk about the R rubric. So this is something of that sort, right? Like sometimes you want to replace with a SaaS solution. Sometimes you want to rewrite it. Sometimes you want to retire functionality. So you pick a modernization strategy and then you sort of implement it, right? Like, so that's almost the most highest altitude visualization of this modernization journey. One of the key sort of things is you need to have the right knowledge to do this, right? You need to know your systems. You need to know how they behave. And then how do you find this right knowledge, right? Like how do you find things about these systems that exist? And as we know, like legacy systems are may have this thing of SMEs, right? So before, and I'm just picking up a timeline that I'll come to why I picked 2022. Before 2022, if you were trying to solve this problem, you'd try to find a subject matter expertise, and you'd sort of sit them down, draw diagrams, go to the board, and try to understand what's going on in their system. Typically, this itself is a challenge because these SMEs are very rare. That's one of the characteristics of legacy system, that there are not enough people who sort of know these things inside out. And so if and when they have the time to do so, they can help you. Otherwise, you're pretty much left on your own. I remember one of the last client modernization problems we worked on, we had 1 hour of calendar time every 2 weeks with this subject matter expert. And if we missed that slot, then we were sort of like, we had to wait for the next slot this person had, right? Like, so that was an option, but it has its own sort of challenges because these people are very few and they're already helping running the business. So they're not really available. They're very well protected, well guarded in that sense. Another one is you could just find a person who could read all the code, like read whatever documentation exists, and then talk to everybody who they can talk to, right? Like, and I guess on paper it sounds fine, but there's an imbalance of humans and machines here, right? Like there's, with legacy systems, there's generally lots of code, like 10,000, 100,000 lines is a challenge for humans. Generally, legacy systems also have millions of lines of code, right? So it's easy to say like, oh yeah, somebody will read the code and sort of understand it. And typically businesses were like, oh yeah, you can spend a week doing that, right? But anyway, that was before 2022. So why were we talking about 2022? Because roughly around November 2022 was when sort of GPT came out, Gen AI started on its hype cycle. I would say it's probably still going on, but this provided an interesting approach or a different approach to solving this problem, right? So the machine could read code and understand code. There were already lots of technologies that could analyze statically analyze code very well, and then Gen AI added the ability to comprehend code, right, to basically explain it in human forms. So that sort of sounded a better approach, and that's why we started building out what we are now calling CodeConcise. And we started with this sort of central axiom in terms of a central sort of assumption, right? Your production system is the most accurate representation of the behavior of your system, right? So we talked about the fact that there's no documentation or there's no tests, so the SMEs are busy. That's all true, but what is also true is that your production system is described in code. Code is structured data, and we could sort of use that to sort of understand the behavior of the system. So I'll hand over to Jonathan. Hopefully I've kept enough time for him.
Thank you, Shodhan. So I'm going to talk about how we build CodeConcise, or what are the different parts that are building the blocks of CodeConcise. So first of all, we use abstract syntax tree parsers. What those tools allow us to do is basically to understand the structure of a code. We are using graph/vector databases to store data. And we are, of course, using large language models in order to enrich the data that we've been storing in those databases. So looking at those in more details. So the first process that we have is something that we call ingestions. So basically, we can take a code base, and on that code base, we can use some abstract syntax tree parser and basically turn the code into a tree representation. So here you see a representation of this tree where each node is representing a software entity, and all the edges between the nodes are representing relationships between those entities, such as dependencies or invocation. So, if you have let's say a Java class that has methods, you could have an edge between them. And if you have a method calling another method, you could have also an edge between them with a different significance. Yeah, there is a video, so I'm going to try to comment it at the right time. Oops, is that me? Okay. Okay, I'm already late. So like what you can see is basically a package that's being linked to a class, and that class is being linked to a couple of methods. So we can have this really narrow zoomed in view of what's happening in a code base, but we can make this much bigger. Well, actually, this is still pretty small. But you get the gist of it. So basically, you have this graph representation of your code base, and that's really interesting to reason with. So I have another picture of what it looks like in the real world. So all of those entities that you can see are multiple software entities talking to each other. You cannot make sense of it, that's okay. But you can see, for example, that we have some clusters, and that might be interesting to see like what's happening like there. You can dive in and see why you might have a particular hotspot or call spot as part of your software structure. So I say that we are using large language models. What are we using them for? So we have this static structure, and what large language models are allowing us to do is basically to extract some documentation out of the code entities. So for example, what we typically do is that we create, for each entities that we want, we can create some functional summaries, we can extract business capabilities, but really we can map it to any other documentation. So that means that if you want to have a quick understanding of like what's happening with a particular area of the code, you don't have to decipher hundreds of lines of code. You can just go through one of those documents. And something comes almost for free. Well, not really, but basically we can do something with those code summaries. So again, we have code. From the code, we can obtain, I say code summary, but any type of documentation. And then we can turn this documentation into vector embedding representations. So in case you don't know what I'm talking about, so you can think about vector embeddings as a list of numbers that are representing the meaning, the semantics of a text file. And the reason we do that is because it's allowing us to, we can then store them in an index. And once they're being stored in an index, what we can do is that an LLM-powered agent can just search this index and answer questions. So I'm sure you've all been using a similar system. And the typical use case that we have for this is to have a chatbot. And we actually have a chatbot in CodeConcise because that's where we started. This is just a picture. I didn't want to have a live demonstration. From my experience, LLM gets a crowd shyness whenever I try to do a live demonstration. But basically, you get the idea, right? You can ask. So this is a source code about some healthcare application, and we can ask, a question about APIs, about whatever we want, and we get a response that's describing whatever we ask about by looking at the code. So how does it work under the hood? So I'm sure many of you are going to be familiar with RAG, but I have to go through it in case you're not. So basically, RAG is just a way of enhancing a response by using contextual knowledge. So when you use a model, that model has been pre-trained on some data, What RAG does is just offer an extra source of knowledge to this model, so it can respond to to specific questions. So if you have proprietary data, if you want to point at, I don't know, something specific at Wikipedia or like whatever, you can apply this pattern. So the model can give some much more richer responses. And so we have a graph. So what we do is that we do not just use RAG, we use graph RAG. So graph RAG is, you could call it a flavor of RAG. So basically, we are leveraging the natural structure of the code base to decide what context is relevant. So usually, if I'm trying to, if I'm having a query about a specific part of the code, like a method of a class, the context would be whatever the dependency of that method of this class are, and then I can get a much more precise or richer answer by using this technique. Okay, but that's, so as Shodhan specified, so earlier, so the software system can be used as a source of truth, but the system is there to support the business, and the software is not always or rarely capturing all of the context, all of the domain context that's present in the business. So like you've all been working in companies, and there's a lot of documentation, and there's a lot of like knowledge that people keep in their head. What we can do with when those documentation exists in a written form is that we can try to map them to a software system. The reason why we would be motivated to do something like this is either to enhance our understanding of the system, or maybe to like validate that the system is actually doing like what we think it's doing. So yeah, things such as ADR, user journeys, any requirements, any documentation, theoretically you can map it using this technique. But what we tend to do is to use a business capability map by default. There's actually, I think, a talk on track 1 this afternoon about business capability map. So you can, if you want to learn more about it, I would suggest for you to attend. But basically, in short, what a business capability map is just a description of the domain that's hierarchical, and basically we can map what the business think of itself to like what the code is actually doing. So if I remember correctly, I have another video where we can see the mapping. So here, all those clusters that you can see in the middle in red, those are business capability that are connected to, I think they're mostly classes from the filter. Sorry about the resolution, but maybe you get the gist of it. And what this is allowing for you to do, this view, is to understand visually the dependency between your capabilities. So for example, if you have a node that's connected to multiple capabilities, you can see that you might or may not have an issue there. There might be something that you might want to look at, or you might just want to know exactly how a capability is being supported across your system. Okay, so I will hand over. Yeah, that's your turn again.
We're running a bit late, so I'm going to be faster with this, right? So, so Jonathan sort of described how we've achieved what we are trying to achieve. And I guess for the next part, we want to talk about the challenges we faced. And one of the biggest challenges with any Gen AI based application is you sort of start inheriting the sort of not so likable characteristics of generative AI, right? So it's difficult to sort of keep that contained. And I'm going to talk about three of the most sort of biggest ones we've faced, and Jonathan's going to talk about some sort of techniques we've started using. So one is observability, right? You have to treat generative AI as a black box. You can't reason about it. You can't debug it. And again, but you don't want that to be inherited by your application, right? You do want to reason about why your application is giving you a certain response, why it's not giving you a certain response. The other one is prompts. When GenAI started, prompts were small. Maybe they were manageable with Windows, context windows, huge now. Prompts are huge. They're almost an API which has no schema, so that because it's just text. The unit is the whole prompt, so you'll have like one A4 page of a prompt, and you can't sort of break it down in units. You can't say I'll test the line 1 of the prompt separately and line 2 of this prompt separately, and then the result will be what is line 1 plus line 2, right? And you can't even semantically version them. A small change like in the prompt language can have a sort of big impact. Like, so prompts itself as an interface of programming are very, very challenging. And I guess the most talked about bit is the non-determinism, right? Like, software engineering has relied on repeatability, right? Same input, same output, same input, run the test again, run the test again. And that's almost gone in a second here, right? Like, there's almost, you cannot guarantee you will achieve the same output. Again, it's a characteristic of the GenAI sort of technology, but you don't want to inherit it for the application that you're using, right? So again, we don't want CodeConcise to inherit all of these things. And so we have to put more and more engineering and guardrails in place so that we can sort of mitigate for some of them. There you go.
Thank you. Okay, I will also try to go a little bit faster. So I'm going to talk about those some of the challenges that Shodhan has been talking about, specifically in CodeConcise. So when we started with prompt development, I would describe our approach as prompt crafting. So basically, like you have an input type, let's say you have a chunk of code, and then you think about a desired output that you would want to have, and you use an LLM to do this. So when I say prompt crafting is just that we would literally just manually write prompts, pass them to the LLM, and usually we can get like pretty good results pretty quickly. And the issue when you get very good result very quickly can be exciting and exhilarating, and then you want to apply it to everything, right? So you want to apply it to different stack, maybe to different domains, to different models, using different LLMs. But the issue with this is that if you change those variables, you may or may not you're more than likely to obtain different results. And the issue is that some of those different results are going to be acceptable, some are going to be more problematic. Obviously the inputs can affect results. So let's say I'm writing a particular prompt. So when I'm saying prompt, I'm talking about prompt template, right? Like you write a prompt with a placeholder, and you can pass a specific input to it, and then you can change the value of this input. So if I pass like class A, it's going to work, and then if I pass class B, it's not going to work. Or it might not work. And we've seen that a lot of things can affect this generation. So the code quality, if you have some comments are lurking, the programming paradigm, even the architecture if you're using multiple pieces of code at once. So obviously models are affecting the results. So we are dealing with multiple projects where they have different constraints on the provider and the model that they can use. So if you use a model, obviously of a different generation, it might be better or worse at producing a certain kind of outcome. And not only that, but obviously the same model can produce different results. Because of this non-deterministic nature. So I implied that we can obtain a generation of output that's undesirable to us, but I didn't define what it was. So when I think about undesirability of like what's generated, we can think about things that are structurally wrong or semantically wrong. By structurally wrong, I mean wrong format or something that's missing properties that we might be expecting. So a common example is you try to generate JSON or YAML, and you end up generating something that's not JSON or YAML, and you might expect to generate something that has a specific property, and that property is missing. And down the line, that could cause issues. So this can be problematic. There's a way to handle this. I will talk shortly about this in a bit. But I think that the most challenging issue is when things are semantically wrong are being generated. It's much harder to catch, and the LLM usually does a good job at pretending that something that's completely false or that's partially true is actually legit and reliable. So looking at the first issue, so structural inaccuracy can break workflows. So again, like looking at our example, so it's more like of a developing mental model. So as a developer, you might design a prompt, and then most of the time it's going to work. And then because you're used to plugging software together this way, you might not design the software in a way that's defensive enough. So one time out of 100, one time out of 1,000, you might get an issue, and that might cause your application to fail. That might cause you to generate something that will be hurtful, as part of your process. So I don't think there's actually like something like very new to the way to handle this. Like has been, if you design an API, you need to think about what happens when somebody is sending to you something that you're not expecting. It's just from experience, it feels a little bit more sneaky when you're using LLMs. But when things are it's hard to say. When the meaning of things is wrong, the thing that you might end up having is loss of time, loss of money, because you generated a bunch of things that are useless. Sorry. But I think that what's very dangerous is the loss of trust. So your user might decide that your solution is like not worth it because it's just producing a lot of garbage. So we had to implement. So we learned the hard way. So like all of those issues that I've been talking about have been actually burning us like more or less at some point. So we had to put in place some guardrails, which I think can be generalized and applied to similar issues. So the way to think about those guardrails is just to go back to good software engineering. So we have those building blocks there again. So we have to think about how to prevent errors. We have to think about how to recover from errors. And we also want to have traceability in place. So what do I mean by error prevention? So error prevention, in this case, again, we're dealing with something that might fail like once in a while. So it's just about reducing the occurrence of this happening. Recovery, it's about having a resilient system. So if something wrong happens, you can recover from it. And traceability in this sense, it's about it's about handling this trust with the user. So it's about trying to implement transparency so the user can understand why something that was generated in the way that it was generated. So then if they have a doubt, they can go to the source and they can see, basically challenge some assumption that the LLM might have been doing or the logic that the LLM might have been using to generate the content it generated. So first I'm going to talk about error prevention and benchmarking. How am I doing for time? Okay. One thing that you want to do is, and that's a little bit, you need to be to have an arty mind to manage to do this, is to identify the archetypes in your data. So you might have, so you might think again, if I go back to like most of like what we're doing, so we're dealing with code and we're passing this code to prompts. You might want to, you are going to need to identify or take a guess on the different type that you have as part of your code base. So are all the classes existing as the same type of entities? Are classes the same thing as methods? Like, do you need to build some specific data sets for a specific type of data? Once you identify your data, you need to think about the size of your data set. So yeah, trying to surf on the previous talk. I mean, maybe think about statistics. A thing that you can use is the law of large numbers. So I don't have equation, sorry. But the way that you might think about it, it's basically you just need to run enough use cases, so it's a reflection of like what would happen in the real world. And then you need to think about the models that you're going to be relying on. So like we happen to have to deal with a lot of different providers and a lot of different generation of models and a lot of like different like versions. You might have a use case where you just have to deal with whatever is the most powerful of the latest of whatever provider you have. But that's something that you need to think about before thinking about benchmarking your prompt. And here I'm going to show you, so like what you can do again, it's have validation for this prompt. So again, the two things that I mentioned, looking at the structure of what's being generated, looking at the semantic content of like what's generated, and you can write validation for those. So for the structure, you can see, okay, if I'm expecting JSON, when I'm running my prompt 100 times, how many times I'm going to get JSON. If I'm expecting like a specific meaning to be generated, how many times am I getting something? How many times am I getting something that's like close enough to what I'm trying to generate? And so okay, so I'll try to. I feel like I'm speaking like very quickly, so I'll try to take. So it's a simplified view of the data that we keep, and that we try to make like visible internally when we are thinking about prompt. So first, like we have those prompt versions. So difference between the first one and the second one is just something that you change within the prompt. The next column is going to be about the structural validity. So how many times did you manage, or did the LLM manage to generate something that was valid? Then you can take a look at the semantic validity. Similar again, like how many times did the LLM generate something that was meaningful enough or like good enough for your use case? You want to tie it to the data archetype that you identified, and you can show the generation number. So like how many times did you try this particular thing? The reason why we put this data is to be very transparent with our users. So if I want to use, let's say, this prompt, and I'm using Python code, I can try to do it, but I need to keep in mind that this has only been tested with Java, so I might have something going wrong. Same thing about the structural validity and semantic validity. So those numbers are actually pretty low, but it really depends on what your use case is. So maybe you can afford to live with a lot of uncertainty. Maybe you're trying to build a high level view of your system like we did, and maybe it's good enough at first to be 90% sure that that what you have like kind of makes sense. So I kind of simplify this, so there's like more there would be like more things to look at. So to break down those numbers, especially when it comes to semantic validity, because the semantic validity is just going to be based on a comparison on individual generations. but I'm running out of time, so I'm going to go to the next part and talk about error recovery. So again, it's pretty straightforward, and it should be something that we do not get burnt with. But yeah, sometimes we did anyway. So it's kind of having this. It's kind of designing applications or API or function to expect a specific format, and then if you pass to them something that's been generated for a prompt, and you get the wrong thing, then you might get in trouble. So instead of expecting something specific, you have to hope for something specific, and be able to prepare for the worst if you get something that's not good enough. And so there's many workflow resilience recovering patterns. They've been tried and tested in different contexts. So you can implement retries so you can check at runtime if the LLM is generating something and retry, and then or you can have fallback or circuit breaker pattern or many other things that you can do there. And yeah, now let me talk about traceability. So what we talk about when we talk about traceability is for the model to tell us why it made the decision that it made. So it's justifying their choices by telling us the clue. So which data did you have access to, and what's the logic behind your decision? So then the user can potentially look at these reasons and invalidate or validate those reasons. That's also a way that we can improve our prompt. So if we realize that the LLM, especially in an enterprise context where you might have some specific language that's in use, the LLM might interpret a notion as something that is not in this context. That would be a place for us to improve the prompts that we are passing to the LLMs. So here is an example of us asking the LLM to justify its choices. So this is a JSON document that's trying to capture the functionalities, and it's a summary of a piece of code. So here you have a role that the LLM interpreted by looking at a piece of code, and here you have a list of functionalities that that the LLM assessed that the code was implementing. So everything is generated by the LLM. So the confidence number is something that you need to not trust or take with a pinch of salt because it's generated, but it tells you at least how confident the LLM thought it should be, given the information it had access to. And what we try to have is justification as well. So it says, okay, I'm thinking that this particular function is creating a new customer, and the reason why I'm deducting that is based on this function and based on this constant. So if you read this and then you realize that, okay, actually this function should not justify this, then you can see where things went wrong. And so this is just for a static document. You can do some similar pattern for what's dynamic. So in chat as well, you can try to make it available to your user to have access to again the level of confidence and the reasoning behind the reasoning behind those choices. Another thing that you should try to make available when possible is the source content that the LLM used. So you can always reverse engineer the reasoning of the LLM. Okay. Sorry, I had to speed through the the last bit. So we started this talk by talking about CodeConcise as a tool to be able to understand a large system according to its structure, but also to contextual information. So we think it's possible, and it's probably possible to apply. I mean, we know it's possible now. Sorry, not we think. But and we think that it's possible to address or to investigate such complex system using a similar approach. But if you do something like this, so you need to understand the cost of non-determinism. So before doing, before trying to use an LLM on such a scale, you should ask yourself how comfortable you are with inaccuracy and which type of inaccuracy you can live with. You need to ensure that as you're going to have inaccuracy, you have a way for your user, you have a way to mitigate risk for the user. And the last thing is that you need to try to implement as much transparency as possible by making the LLM choice visible, and also providing user by as much information in terms of the confidence matrix or the reasoning as possible. Okay. So yeah, that was it. Those are the faces of the CodeConcise internal team. If you have any questions, you're going to be able to ask them now, I think. But if you don't get your question answered, please feel free to talk to Shodhan and I during the day.